Okay, so this is Jana, and I'm going to be explaining the 3.7 till 3.12 physics course practice quizzes. Okay, so let's start with 3.7. Okay, what we need to know first thing is horizontal is like this, obviously, and vertical is like this. Okay, so the vertical is the y, and the horizontal is x. Okay, and we know that y is sine and x is cosine from trigonometry. Okay, so with that knowledge, let's answer these questions. Okay, so when they're asking for horizontal component, you multiply the force by the cosine of the angle. For example, let's call this angle A. Okay, so cosine of angle A. So for us, the force is 10, so 10, and it's because it's horizontal, so it's x, so it's cosine, so cosine 50. And remember this because you might get it wrong. It has to always be like the angle to the x-axis. It can't be this angle here. It has to be the angle touching the x-axis, okay? So 10 cosine 50, when you do it on your calculator, 10 cosine 50 is 6.4, and one of our choices here is 6.4. So that's why this is the answer. Okay? And then vertical component, like we said, is y. So, and y is sine. So force times sine of the angle, which is 50, equals, and the force is 10. So 10 sine 50, and it's equals 7.66, so 7.7 if you round it. Okay, and it's very simple. Okay. Okay. X component is the horizontal, and y component is the vertical, if you memorize it that way, or x for cosine, y for sine. Okay, so let's start with the x component. We want the net force, and we have two angles. Okay, so we need to find the values of both these angles and then add them. Okay, and like I said, make sure that their angle is hitting, it's angling with the x-axis. Okay, so 17 cosine 28 equals, what's 17 cosine 28? You go to your calculator. 17 times cosine 28 is 15. 15.01. Okay, what I like to do, so we don't round anything up in the middle, because rounding in the middle always like gets you some sort of decimal wrong. Okay, so I don't round in the middle, I don't round, and I keep it. So I do answer plus, now we're going to find this angle here. We know from geometry that we have the quadrants. This is the first, this is the second, this is the third, and this is the fourth quadrant. Okay, no, I flipped the third and the fourth. Sorry. This is the third, and this is the fourth. We know, like I taught you in one of the geometry course revision questions, it's all students take chem. Okay, so the A stands for all of them are positive, so this here is a positive, this here is positive, and then all students say S. So sine has to be different. Okay, we know that sine is y, So here, sine is the only one that's positive. So sine is positive, the rest is negative. Okay, and then all students take, so T stands for tangent. So tangent here is the only positive value and the rest are negative. Okay, and then here all the students take chem. Chem starts for chem. C stands for cosine. So cosine here is the only one and negative. Okay, and the rest are positive. Let's remember this. We know the x component is cosine, and we know that cosine in this quadrant here is negative, right? So let's cancel all of this and let's go. So it's negative 5n cosine 53, because we found out that cosine here is negative. Okay, and also sine, so let's remember that too. And then if we go on our calculator, we do negative 5 cosine 53, you get negative 3.009. Like I said, don't round, okay? So take the answer from the other question, do answer minus, because it's negative, okay, minus 3.009, whatever the rest of the equation is. You get 12.001, so on. And since they want them to the nearest integer, that means it's 12, and that's your answer. Okay, now for y component, we know the y component is sine. Okay, so and sine is vertical. Okay, so it's vertical here. Okay, let's remember that because we have to do an extra step in this question. Okay, so y component, that means it's 17 sine 28. We get, you get 7.98, so on. Okay, so you do answer, and we know that sine here is negative, so answer minus 5 sine 53, and you get 3.98. Now let's keep that value in our calculators. Here we have extra 1 newtons. Okay, that, and it's going to the horizontal the y-axis, which is the horizontal, which is sine. So we have to add this 1 to our answer for the sine, because it's on the sine, like y-axis. Okay, that's just the rule. Okay, so answer plus 1, and you get 4.98. Nearest integer, you get 5. Okay, here this is just 1, so you don't have to do net force, you don't have to add anything up. Okay, here we have the force is 30 and the angle is 45. So for the vertical, it's sine, so 30 sine 45 is, on your calculator, 30 sine 45, and you get 15 radical 2, which is 21.21, so on. Okay, they want to 3 significant figures, and if you round 21, it becomes 2 because 1 is less than 5, so it's 21.2, and that's your answer here. Okay, now for horizontal, it's cosine, so 30 cosine 45. Okay, so on your calculator, if you do 30 cosine 45, you also get 15 radical 2, which is 21.2, and that's your answer. And it's fine if you get the same answer for the vertical component or horizontal component. Just make sure of your answer, but most of the time it's fine. Okay. Okay, this is literally the same thing, okay, just with different numbers. But make sure you read the question. This says it's making an angle with the upward vertical. Okay, so this is your graph. This, for example, is your angle 30, but they're saying it's going with the upward vertical. This is y, and this is x. You remember what I told you why it has to be making an angle with the x-axis and not the y? So we have to flip it to find the angle for the x-axis. We know that this angle here is 90. So 90 minus 30 equals 60. So that's the angle we'll be using, okay? So horizontal component, cosine. So 60, which is the force, cosine 60. On your calculator, you get 30, okay? Then for vertical, which is sine, so 60 sine 60, because that's the angle we found. Do it on your calculator, you get 51. Wait, let me do it on my calculator. 60 sine 60. You get 30 radical 3, which is 51.9. In the choices, they give you 52 and they give you full numbers. They don't give you decimal numbers, so they're rounding it up. So you get 52, which is 51.9 rounded up. And that's the 3.7 quiz done. Let's do 3.8 now. Okay. So, Newton's third law states, you have to memorize this or understand it, whatever, okay? Newton's law states that for every action, there's an equal in magnitude. Remember, they might switch it up for you so you can forget and this is why you have to understand it and not memorize it, okay? So equal in magnitude and opposite in direction, reaction, okay? Equal is always magnitude, okay? Opposite is always direction. We learned this last year, grade 8, so you should remember this. If you don't, just understand it. Equal is always magnitude, opposite is always direction. In Newton's law, third law states, for every action, there's an equal in magnitude, an opposite in direction, reaction, okay? Question 2. This might confuse a lot of people. It confuses me too, but I got it, okay? Because it's very simple. This is why you should always read the question when you're solving the exam, okay? So, the ball of weight 3 newtons, so that's our force, okay, is falling in the air. At some moment, it experiences a drag force of 1 newtons. Drag force is air resistance, okay? So it acts on air. Let's just remember that. Weight is the pull of earth on an object, okay? So, the force exerted by the ball on earth, as it falls, they gave us it's 3 newtons. And we know weight always directs downward, it always directs upward, okay? So, upward. The thing that directs downwards is the normal reaction, okay? So, the second question. The force exerted by the ball on the surrounding air, they told us drag deals with air, is what? How many newtons? They gave us the answer. It's 1 newtons, okay? And directed downward. Because how do you get air resistance? Air resistance is when you're free falling or falling down, air pushes up to the surface of the thing that's falling, okay? So it's downward. Okay, third question. Okay, here, let's focus on the diagram for a moment. These are 2 objects, object B and object A. Let's remember that now, okay? They're asking you in the first part, what's the magnitude of the force acting on A? So this one here it's 5 newtons. It's showing you, so it's 5 newtons, okay? Now, why don't these forces cancel each other? Because we didn't say 0 newtons here. This gives you a clue that it isn't 0 newtons because they don't cancel. If they said it cancels, that means it's 0 newtons, okay? So let's see. Why don't they cancel on each other? because there's two different bodies. We know that Newton's third law, Newton's like laws, they act on the same body, okay? That's why they cancel each other if they have the same magnitude, okay? So here they don't cancel each other because they act on different bodies and not the same. If they act on the same bodies, this is supposed to be 0 newtons because both of them are 5, okay? Now, what's the symbol represented by the force exerted by A on B? If you watched the 3.1 and till 3.6 video for physics on Walid's channel, which is this one you're watching right now, you would know how to represent this force. If you didn't, you should go watch it right now. But you always, first thing, whenever they want you to represent a force, you put F, okay? Exerted by an object on an object. The first object or first subject, whatever that comes, you put it at the beginning. And the second one, you put it after the first one, okay? So FA on B. If they told you exerted by B on A, it will be FB on A, okay? Now question 4. This is like the first question. Like we said, equal is always magnitude, opposite is always direction. And that's the 3.8 quiz done. Okay, now 3.9. 3.9, they're saying box B is dragged on a rough horizontal surface. Okay, on a rough horizontal surface. So we already know that F stands for friction, is one of the forces. They want you to the net force exerted by box F on FSB. Here, the force in this at the beginning of this question, it's force B. Wait, B. B on S, because B came first and then S came second, okay, like I said in the last question. So S on B is gonna be the opposite, the same magnitude, opposite direction, like we said. So it's gonna be opposite in direction, and this is the only one that's opposite in direction, like the same, okay. Let me explain what opposite in direction means. Doesn't mean it's in any direction that's opposite. It has to be kind of the same, okay? Just in opposite directions, okay? So for example, if we have this, it's opposite direction. This is going down, so its opposite direction will be up, okay? This is the same as this answer. And this second one, it's not the same, same type of force, okay? Question 2. Okay. They're telling you box B is being pushed on by force F on a rough horizontal surface. So rough horizontal surface is friction. The surface reacts to this motion by exerting a force on the box. The force has two components. Whenever they say the surface reacts, that means it's the normal push or normal reaction, whatever, okay? So the component that tends to prevent the box from going through the surface, because you can't have that, okay, is the normal push or normal reaction. It's the same thing. The component that prevents the box from sliding down, when they say sliding down or going through and not going through, or sliding down or falling down, it's always friction. And that's 3.9. Okay, 3.10. Okay, when you hang something from a string, rope, or anything, if you watch the 3.1 to 3.6 video, you would know that anything, string, rope, anything that it's a cord or something like that, it's tension. So that's one of our answers. Okay, and then what? The sphere hangs from the ceiling. That means its weight is pushing it down. Okay, so weight is the second. Why is normal force not one of them? It's because it's not touching a surface. That means you can't have normal force if you don't have a surface. And then friction, it's also because you don't have a force, a surface. And electric, you don't have any electricity or something like that, so that's already gone. So it's tension and weight. Okay, here, if you also watch the first video, it says immersed into water. Whenever we have water, fluid, anything that's fluid, it's always upthrust, okay? Upthrust is always one of our forces, okay? And then by held up by a cord, like I said, cord, rope, anything that you hang something from, it's always tension. So upthrust and tension. Okay, now what pulls the object or the block down? It's weight. Okay, so now let's fill in the table. They already give you tension. We know that weight goes down and normal push goes up, so normal reactions already cancelled because nothing's going up, so it's weight. And then upthrust was one of them, so we put upthrust. Now, why is air resistance not one of them? Air resistance only deals with air, okay? So that's why it's not one of them, because we don't have air here. We only have liquids. Okay, question 3. Let's start with the easiest one, which probably has to be this, okay? It's going straight down. We have tension and we have weight. What from these choices here have something with tension, so have something hanging? The key word here is hanging, so that's why that's the answer. Now, for this one, okay, we have weight and we have a P. I don't really know what a P is, to be honest. I don't know what a P is, okay? But you can imagine that. We'll just keep this for the last one because this one's pretty tricky, okay? For this one, okay, we have weight, we have friction, we have newtons, force, okay, normal reaction, okay? So when you see plane means surface, okay? What did we say about surface? When we have surface, we always have normal reaction and friction. So that automatically puts that to that. We already solved this. And then what keeps this stays for this one. I really don't know what P is. If I don't know something, I keep it to the end. If I I find all the other answers, and then I'll keep it to the end and see what stays free for it, okay? Okay, like I said, you have to memorize everything about free body diagrams, okay? So we know it includes contact forces because it includes all forces. So all forces, the forces are into two main parts: contact forces and action at a distance. So this is correct. It's a simplified sketch of all forces acting on an object. That's also right because we know it's a sketch about all forces. It includes forces exerted by the object. No, it doesn't. It only includes forces exerted on the object. It only includes contact forces. No, it includes contact forces and action at a distance. So that's wrong. And it can be used to represent action and reaction forces. No, it can only be used to represent all forces, not action and reaction. That's 4. 5. The book rests on an inclined plane. Okay. Plane, surface, like I said again. Whenever we see surface, we friction. Tick, please. Okay, friction and normal. And then we have weight, that's kind of always there too. Okay. And tension, no, we don't have it. It isn't hanging by something. The keywords for tension, yeah, cord. I'm not gonna write it. Yeah, cord. Yeah, hanging. Yeah, cord, rope. Any of these hanging stuff. Okay. And then upthrust is fluids or liquids. Okay. 6. Free body diagrams, like I said, free body diagrams, you have to memorize the stuff for them. Okay, so object, which can be, yes, it can, it's always drawn, yeah, a box, yeah, a point, so that's right. Okay, why is it not ticking? Khalas, we'll forget about it. Okay, force is represented by arrow pointing towards the object. No, it doesn't have to be pointing towards the object. So for example, if I draw like a free body diagram and it's okay, so for example, this is like a normal force. Arrow is always pointing towards the right. It doesn't have to be towards the object. The object is here. It's not pointing towards the object, so this is wrong. Okay, and then magnitude of a force should be added next to the given force if given. Yes, because if you have a force, you should always give the magnitude with it. Unknown forces should not be drawn. No, all forces should be drawn if known. So this is also wrong. All given values should be added on a FBD. Yes, FBD stands for free body diagram, by the way. Okay. Now 3.11. Okay, first question. Okay, this confused a lot of people, but this is how I understood, so I'll make you understand it. Okay, so since we want it to be stationary means it will be equal to 0 newtons. We need both sides to be equal. So what can we add to this side, the smaller side, to make it equal to 5 newtons? So you can do 5 minus 3 equals 2, or just common sense, you add 2 to what side? The left, because this is the smaller one. Okay, so that's how you make that stationary. Constant speed is also 0 newtons, so you do the exact same thing. So this is also the same. Now, this is how I understood this. Okay, the block moves to the right with a net force of 8 newtons. Okay, so net force of 8 newtons. So to the right, which is this side, so this is right, and it's 8 newtons. Okay, now we need to, whatever we add here, we also need to add here. Okay, so here, how much are we gonna make till 8? We add 3. Okay, and here, how much are we gonna we're gonna add the same thing, so 3. This is how people made me understand it. I don't think it's the right way to understand though, so I'll explain to you how I want you to understand. To be honest, their way is also right, but I don't know if it works on everything, so I'm gonna explain to you why they got this. Okay, so they want to see more. For now, if you, what I know to be true is, okay, when you minus these two by each other, because they're not the same force, you get 2 newtons, right? Okay, they want for this number to be a thing, like some number, okay, that when you minus it from 3, you get 11, okay? Because they're 8, sorry. 8. They want it to be 8. So what plus 8, so this is how you can solve it. 8 plus 3 is 11. Okay, so what can you get? What do you add to 5 to get to 11? 6. And what side? Right. This is how you should be thinking of it. Some people just think uncommon sensely and do plus 3 on both sides. That does not make sense, so you should think that way. Okay. Question number 2. Okay. They want the block to be stationary. Like I said, stationary is 0 newtons, so they have to be equal on both sides. This, okay, sorry. This is going up and it's go down. First thing, it's not going in opposite directions, it's going in completely different directions. So we can't even cancel any of them. Here, both of them are going opposite direction and they look like they have the same magnitude. So we can keep this as one of the choices. Okay, now these two opposite direction from this, so we can't cancel. This also opposite directions, we can't cancel. So this is the only one we have, so B is our answer. Okay, here they're asking at what time, the time at which the forces acting are balanced. Balanced means they're equal to 0 newtons. Okay, so 0 meters per second. They're asking for the time. We go to the graph here. We go here. Where is 0 here? So we go to the graph. We pinpoint it and then we go down to look at the time. It's at time 2 seconds. So that's your answer. It's very, very simple. Okay, so when we have 0 in this question, they're asking what are the possible outcomes of a 0 knot force. We said when we have 0 knot force, it's either at rest or moving with constant speed. Constant speed is kind of the same thing as constant velocity. So let's analyze the choices. Here we have remains at rest. Yes, that's one of the choices we had. It decelerates. No, because decelerating is moving with some sort of speed, so it's not constant. So this is wrong. Moves along a straight line. It has to be a straight line with constant speed and constant velocity. Okay, so yes, constant speed. Object moves with constant velocity. Yes. Moves in a circle with constant velocity. No, it has to be in a straight line. So that's that question. Okay, here they flipped around the question kind of. They flipped it around. Unbalanced force, constant unbalanced. Okay, they set a constant unbalanced force, so it can't be decelerating at a not an increasing rate or decelerating at a decreasing rate or accelerating in an increasing or decelerating rate. It has to be decelerating or accelerating in a constant rate or a constant acceleration or constant velocity. It has to decelerate or accelerate though. Okay, so here it says object remains at rest. That's a complete no because they said unbalanced. Here it's decelerate with a constant rate, then yes. Accelerates with a constant acceleration, then yes. Moves with constant velocity? No, it doesn't move with constant velocity. It accelerates or decelerates with a constant velocity. And accelerate with an increasing rate? No, it has to be a constant rate. Okay? And that's 3.11. Let's go to 3.12. Okay, 3.12 is only 12 questions. That's easy. Okay, so this question, they're asking you, what does this graph illustrate, or what relation does this graph illustrate? This graph illustrates Newton's second law. I'll tell you why. Because Newton's second law is F equals ma. Okay, here we have force and we have acceleration, so that means we have two of these, so we're finding a. So this line is a. That means this is Newton's second law. Okay, now we want to find the mass. Okay, so we know that F equals ma. We have a here, this here is a, and this is F. Okay, so yeah, we either flip around the height, we flip this around to find m, or we use the same thing, just flip it around when we get the numbers. I would like to use the same thing because it's easier for me. Okay, so let's go here, 0.2 and 1. Okay, so the force is 0.2, so 0.2 equals m times a, which is 1. Okay, so here we get m equals 0.2. Okay, now this is in grams. Okay, they want us to give this in grams. This is in kg, so we multiply 0.2 times 1,000, yeah, and you get 200. And that's the first question. Now let's go to the second question, which is the last question. Okay, we literally solved this right now. We know the rule is F equals ma. A is acceleration. You get what I mean. It doesn't need to be nice handwriting. And the F is force. Okay, then what is am? It's mass. That's literally it. That's 3.7 to 3.12 of the physics course revision quiz for periodics final whatever. Thank you. Hopefully you understood.